Hi, this is Mrs. Kidman, and this is the last video about absolute value functions. This video is going to put it all together. So the last three that we've watched have talked about how the values of a, h, and k affect this function. And it kind of explains to us how, when we start at that parent function of f of x equals the absolute value of x, our function is shifted based on what those values are. So let's summarize those shifts. So k, here's a quick reminder of what our function looks like here. K times the absolute value of x minus h plus k. So this k on the end, it tells us whether or not the function shifts up and down, depending on if it's positive or negative. The h is going to tell us whether or not our function is going to shift left or right, depending on whether it's positive or negative. The a has two different components. It's going to tell us whether it's going to face up, or it's going to open down. And it's also going to tell us if it's going to get thinner or if it's going to get wider. Those are the characteristics of that A. So combining all of those, let's see what happens. So the first question here has us starting at our original function, f of x equals the absolute value of x, and it wants to know, how do I get from there to this new function of g of x equals -2 times the absolute value of x minus 1 plus 3. We want to know, how does it get there? Well, when I do this, I like to start from right to left when I describe those shifts. So the first thing I look at when I go right to left is this plus 3. Now I can see that this plus 3, when I look back at this, is my k. So if k is positive because it's a 3, it's going to shift that many units up. So I know that that first step is that we are going to shift up 3 units. Now what that first step there looks like as a function would be the absolute value of x plus 3. And we have that plus 3 component here. So that's us shifting up. The next number that I run into here is going to be that -1. And that -1 is our h value. So h, remember, it has a minus right here. So is that really a -1? No. In our problem here, this is just a regular 1. So 1 is a positive number, so that means we're going to shift 1 unit to the right. And that's what we're going to write here. We are going to shift to the right 1 unit. And what this new function looks like when we do that is going to be the absolute value of x minus 1 plus 3. That's what happened with that second step. Now the third part that we're going to look at here is this next component, this 2. So a being 2, we're going to look at it here. A is 2, so the absolute value of a, well, the absolute value of 2 is 2, and 2 is greater than 1. So we're going to have a vertical stretch, which means it's going to get thinner. So I'm going to write that it has a vertical stretch, and we say it's by a factor of 2. Okay, because instead of it being 1, 1, we're now at 1, 2. So we've gone up. It's a vertical stretch by a factor of 2. And if we were to write that, that third step takes us to a function that would be 2 times the absolute value of x minus 1 plus 3. Now that's real close, but the last thing we have to look at here is this negative sign. So what does that negative sign do? How does it affect our function? Well, as we look up here, if a is negative, it reflects across the x-axis. So that's what we want to write here. Reflect across the x-axis. And if we do that, step 4 will give us this function right here. So that's what's happening here, is we are shifting that function from one place to the next. And that's what those values of a, h, and k do, is they show us how they shift. So using that idea, I want you to just figure out, how do these equations up here match with these graphs down below? Take a minute to pause the video. Use that page that you have of notes that tells us how k affects it, how h affects it, how A affects it, and decide which functions are the ones that match. After you've spent time matching those, unpause the video and I will have those answers revealed for you. Great, now that you've taken the time to look over those, let's match these graphs. So this first graph here, we know that it's going to be shifted 2 to the right and it's going to be facing the opposite direction. So that means that 1 is going to match with D because this one is shifted 2 to the right and then it flips to the opposite direction. So this one is number 1. 2 is going to shift 2 to the right and 2 up. And so we are looking for one that shifts over 2 up 2, and that is going to be C. So this is number 2, because you can see that we've shifted over 2 and up 2 with that function. Now number 3 has 3 parts to it. We've shifted down 2, to the left 2, and flipped ourselves over. So let's look at what happens. So we're going to shift down 2, to the left 2, and flipped ourselves over. So this one is E, because it's shifted to the left 2, it's gone down 2, and then it's flipped over. Now 4 shifts 2 down and 2 to the right. So shifting 2 down and 2 to the right puts us here at F. So 4 is F. 5 has us shift to the right 2, but it gets skinnier. And so that one will leave us with A. And so A is 5. And then the last one here, we could match it by process of elimination, or we can check. This one is going to go up 2, to the left 2, and then flip over. So it goes up 2, to the left 2, and then flips over. So this one is D. So now you can kind of see how those different values, that K, H, and A, affect these different functions. Based on this, we can determine, given whatever A, H, and K is happening, where it's going to go. Another quick reminder is that this is vertex form. So remember, the vertex of our function is going to be at HK. So I can actually check each of these by looking at their function, or by looking at their vertex of the function. So this first one, there is no K, so K is going to be 0. And H is going to be 2. And so I can look in graph D here. I see that the function was at 2, 0. Perfect. For 2, I can see that it's at 2, 2. So I can look at these graphs and see which one has a function at 2, 2. Oh, it was C. Perfect. Same thing here. This one has a function at -2. -2 is where that vertex is. So I can look which one has a vertex at -2, -2. E. Same thing here. Which one has a vertex at 2, -2? That one's going to be F. Which one has a vertex at 2, 0? Oh, that is both 5. That is both A and D. So then I have to look at that A value to determine which one it is. Now D faces down and 1 has a negative sign. So that's how we know those two match. So remember, just looking at the vertex won't guarantee that you'll get it, but you can rely on that vertex and the A to determine which one is which. And lastly, number 6 has one at -2, 2. And so I can look here and find this one is at -2, 2, and see that this one is number 6. And there you go. That's how we can use the fact that it's in vertex form to also help us in deciding how these shifts occur. If you have any other questions on how to work with absolute value functions, please reach out to Mrs. Kidman. You can email her, come in during pack hour, come in before school, or come in after school, whatever works best with your situation. Also, don't forget to work on your assignment associated with this. That's going to be in the textbook. It's chapter 1.1 is on page 8, and it's going to be 5 through 21 odds, 23 through 26, and 33 through 41 odds. You can either access the textbook on Big Ideas Math, or you can find it on Canvas. Thanks.